Hello everybody. In the previous video we learnt about uh, vertical asymptotes and horizontal asymptotes. In this video we will learn how to apply transformations on the simple function, that is y is equal to 1 over x, and obtain different rational functions. So this section, this video is titled as transformations of 1 over x. So you can apply what all transformations you learned, that is horizontal stretching, vertical stretching, vertical shrinking, horizontal shrinking, and moving towards right, moving towards left, moving upwards, moving downwards, the graph. Okay, so you can apply all the transformations on y is equal to 1 over x, and you can obtain a rational function of the form r of x is equal to ax plus b divided by cx plus d. Okay, so this is the standard form of the rational function. Okay, so and such functions are called as linear functional transformations. Okay, so for example, if I have to consider a is equal to r of x is equal to 2 over x minus 3. So if you're asked to graph each of the rational function and state the domain and the range, so it is very useful or easy to do it in terms of transformations of 1 over x. So let us see how we can do that. So let f of x is equal to 1 over x, correct? So you can see that you have something called as 1 over x minus 3, right? So r of x can be written as 2 times 1 over x minus 3. We can, right? So that would be nothing but 2 times f of x minus 3. Okay, so this particular thing would be shifting the graph f. So this would be shifting the graph f by 3 units, correct? And 3 units to right. Okay, 3 units to right. And if you multiply 2 to this one, after shifting, you are nothing but you are stretching vertically by a factor 2. So you are stretching. So this becomes very easy. And we know that what is the vertical asymptote for 1 over x? It is nothing but x is equal to 0. But that is when 1 over x, if you have only x in the denominator, but you have shifted the graph by 3 units to right. So 0 plus 3 would be 3. So vertical asymptote is the line x equals 3. And what was the horizontal asymptote? There is no change like horizontally, correct? So horizontal asymptote remains as it is, that is y is equal to 0 itself. Because all the shifting is happening vertically, that the stretching or anything, the transformation is applied vertically. So there is no change in the horizontal paths or horizontal points of the graph 1 over x. So the the horizontal asymptote is same as that of 1 over x. So that will be y is equal to 0. Okay, let us do another problem. This is another example in your book itself. So this is example B. So which states that if your s of x. So graphing becomes easy with this as well. So like you just have to find out tables of values for x and 1 over x and apply the transformations that we learned, like you learned how to do it in section 2.6, right? So just alter the input values or alter the output values based on this original function, that is x and 1 over x. So find out the table values and plot it. So that is how you plot the rational functions, and you can state the domain and range after you plot the graph. So you can see the graph and state the domain and the range. Okay, so there is this example which says that s of x is equal to 3x plus 5 divided by x plus 2. Okay, so upon division, long division, so let us do the long division. 3x plus 5 x plus 2, 3x plus 5 is divided by x plus 2, so you get this to be 3x plus 6. So this is nothing but -1, correct? So how can you write s of x as in terms of using the division algorithm? You can write it as 3 minus 1 over x plus 2. So rewriting the terms, this can be written as -1 over x plus 2 plus 3, correct? So if the original function f of x is 1 over x, so the first term, what is happening to the first term? S of x is nothing but negative f of x plus 2, correct? Negative f of x plus 2 plus 3. So this is the transformation that is applied on 1 over x to obtain s of x. So using the things that you learnt in section 2.6, that is applying the transformation. So what is happening here? You have if you multiply negative, or before that you are adding 2 to all the input terms, right? So that means you are shifting the graph for 2 units to left. So this would be shift graph to left by 2 units, correct? And if you are multiplying by negative sign to the output value, you are nothing but reflecting in the x-axis, correct? Reflecting in the x-axis, and you are adding 3 to the final function, that is negative f of x plus 2, negative f of x plus 2. So that means you are shifting the graph upwards by 3 units. So the whole thing, the whole transformation looks like shift the graph to left. It's a combination of shifting the graph to left by 2 units, reflecting in the x-axis, okay, and move upwards or shift the graph upwards by 3 units. So combination of all the transformation is on 1 over x is nothing but s of x. So that would give us our vertical asymptote to be you are shifting the graph to left by 2 units, so it would be 0 minus 2. So vertical asymptote is nothing but x is equal to -2, and horizontal asymptote is y is equal to 3. Okay, so yeah, because you are shifting the whole of the function, that is 1 over x, by 3 units upwards, so y will be equal to 3. Okay, there is a horizontal change in y or f of x. Okay, so with this I will end this video, and I'm giving quiz 3.6.1 here itself, and I know that in the previous video there was question 3.6.1. you just have to continue the question with this question also. So write both the answers in excuse me, I'm sorry for that, in 3.6.1. okay, so write I think I gave you number 12 or something in the previous question 3.6.1. so this would be number 18. So number 18 in the book, write number 12 and number 18 under the same question number. So you need not get confused by this. So in the next video, we will learn about more on asymptotes, like more about finding asymptotes as well as graphing rational functions. So see you in the next video. Thank you.